Have you ever heard of iron rain? No, not some heavy metal band. I mean actual iron that falls from the sky like rain. It might sound crazy, but scientists have actually discovered this strange phenomenon occurring on a very faraway exoplanet, but it's not quite what you might think. It's not water that's falling from the clouds on this world. In fact, it's so different from the rain we know that it's more accurate to call it iron snow, and we don't know if it even lands on the planet at all. Now let me explain. This discovery was made by an international team of researchers who were observing a WASP-39b, which is an extremely hot gas giant around 700 light-years away. As far as astronomers can tell, this planet is roughly twice the size of Jupiter, and it orbits a star that is smaller and cooler than our Sun. The researchers found that the planet receives radiation powerful enough to vaporize iron, which then forms clouds that eventually reach a critical point where the iron condenses into a liquid before falling onto the planet's surface as, you guessed it, iron rain. Now here's the thing. It's not technically rain because no one has actually seen this iron fall onto the planet. Instead, the scientists detected this by looking at the light from its star as the planet passed in front of it. As it happens, every time the planet passes between us and its parent star, the light from the star is filtered through the planet's atmosphere, allowing the astronomers to determine its chemical composition. Each time they saw this, they noticed that certain wavelengths of light were being blocked, indicating that the light had been absorbed by specific elements. They saw the usual stuff like hydrogen and helium and oxygen, but also some more exotic stuff like sodium, potassium, and iron. The researchers believe that the iron is coming from the planet's core, which is gradually boiled off by the intense heat on the planet's surface. We're talking about temperatures up to 18,000 degrees Fahrenheit or 10,000 degrees Celsius. That's hot enough to melt just about anything, including iron, which has a melting point of 2,800 degrees Fahrenheit or 1,538 degrees Celsius, and on WASP-39b, the pressure is so great that it squeezes the iron atoms close together, causing them to bond and form solid iron. Then, when the iron reaches a certain height in the planet's atmosphere, it condenses into a liquid and eventually falls onto the surface as rain, or perhaps it doesn't. After all, it's possible that the iron could be lost to space before it reaches the ground. It's also possible that it could evaporate again before it hits the ground or react with other chemicals in the atmosphere. So while we can't say for sure that it's raining iron on this exoplanet, we can say that there's definitely a lot of iron in its atmosphere. One theory is that the iron is coming from the planet's core, which is gradually boiled off by the intense heat on the planet's surface. If that's true, then the amount of iron in the atmosphere should be increasing over time. Eventually, it could become so thick that it blocks most of the light from the star, making the planet even hotter and speeding up the process. In other words, the iron rain could be just the beginning of a very bad situation for any life that might exist on this planet. Maybe it's already too late for it though. There are a few reasons why scientists think that there probably isn't any life on WASP-39b. First of all, it's incredibly far away from its star, meaning that it receives very little heat and radiation. Second, it has no solid surface. Since it's a gas giant, any potential life would have to be floating in a sea of molten iron. Third, it's very likely that the planet is tidally locked, meaning that one side always faces the star and the other side is always facing away. This means that one side of the planet is extremely hot while the other side is in total darkness. There's also a strong possibility that there's no atmosphere on the dark side, so any life that evolved there would quickly die out when the iron rain started. But even if there was life on the bright side, it wouldn't last for long anyway. The constant bombardment of radiation would eventually kill all living things. So even if life did evolve on WASP-39b, it probably wouldn't last for more than a few million years. Fortunately, there's no need to worry about this happening on Earth. Even though it's theoretically possible for iron to rain on our planet, it's extremely unlikely for it to happen here. We'd need much higher atmospheric pressure or much lower temperatures. We could probably get something similar to iron snow, but not actual rain. But let's say that it did start raining iron on Earth. How bad would that be? Actually, not as bad as you might think. It would definitely be dangerous, but not as dangerous as, say, acid rain. Iron is less toxic than many other metals, and it's also an essential nutrient for humans and other animals. So while iron rain would contaminate our water sources, it wouldn't be the end of the world. We could probably find ways to filter out the iron and use it for other purposes. And as for the plants, well, they might not like it, but they'll probably adapt eventually. In the long run, iron rain wouldn't be a major problem for life on Earth. The real problem is that it would be really annoying. Imagine trying to drive down the street when the windshield wipers can't keep up with the iron falling from the sky, or try to take a shower without getting covered in iron. Good luck with that. And forget about barbecuing. Any food that comes into contact with iron will immediately rust. You might as well throw away your entire kitchen. On a serious note, iron rain is just one of the many strange phenomena that have been discovered on with thousands of planets out there. It's only a matter of time before we find one that's even weirder. Maybe someday we'll discover a planet where it rains diamonds or gold. Now that would be a lucky break. Scientists just discovered strange iron rain falling on this very far-away exoplanet WASP 39b. It's about 700 light-years from Earth, and we didn't even know that it had an atmosphere until now. So how did they find out? What makes this exoplanet so special, and why should we care? Well, it can teach us more about our own planet, so let's get into it. When you think of rain, you probably think of water, right? But on some planets it might be raining something else entirely. This is a pretty well-known image of Earth with rain, but if you were standing under one of these spots, you would definitely not want to put your hand out like this, because depending on where you are in the universe, what falls from the sky can vary quite a lot. In some places it might be raining glass, while in others diamonds or even iron. Scientists have discovered strong evidence for a global iron rain cycle on WASP 39b. But how exactly does iron rain form? It all starts with temperature. The daytime temperatures there reach around 1100 degrees Celsius. That's hot. And at those temperatures, metals such as iron tend to evaporate. They go from being a solid or liquid into a gas called a vapor. But when the temperature drops at night, the metal vapors cool down and then they condense into clouds. Eventually they become heavy enough to fall back down onto the planet's surface as rain. WASP 39b has been a real busy bee. When this exoplanet was first discovered in 2007, scientists only knew that it orbited a star and that it was about half the size of Jupiter, but twice as massive. But with the help of the Hubble Space Telescope, scientists found evidence for a thick hydrogen atmosphere on the planet. And in 2018, they used the same telescope to observe a transit in which the planet passed between us and its star. This allowed them to look at the light that was filtered through the planet's atmosphere before reaching our telescopes. By analyzing the light that made it through, scientists were able to identify what part of the light spectrum was being absorbed by certain chemicals, and from that they could identify what part of the light spectrum was being blocked by iron. Iron usually doesn't exist in a gaseous state on planets that we know of, so seeing this really helped to confirm that iron rain is happening on WASP 39b. So why does this matter? Why should we care about a weird exoplanet that's 700 light-years away? Well, discovering new exoplanets and learning about their atmospheres helps us better understand the diversity of planets out there. It also helps us learn about the atmospheres and material cycles of planets, not just on other worlds, but here on Earth too. Atmospheres are extremely important because they tell us how planets evolve and interact with their environment. It's kind of like a record of the planet's history, but unfortunately it's often difficult to study them, especially if the planet doesn't have a lot of atmosphere like our moon. That's why astronomers get excited whenever they discover a new exoplanet with an atmosphere. It gives them another opportunity to search for answers to big questions about planetary science. For example, astronomers want to understand how rocky planets like Earth form and evolve over time. They also want to know what kinds of atmospheres different planets have and how those atmospheres change over time. And finally, they want to find out whether there are planets out there that could support life. In order to answer these questions, astronomers use various techniques to study the atmospheres of exoplanets. One of the most common techniques is called spectroscopy, which involves breaking down the light from an exoplanet's atmosphere into its different wavelengths. By analyzing the resulting spectrum, astronomers can identify the chemical elements present in the atmosphere. Another technique is called photometry, which involves measuring the brightness of a star over time. By looking for dips in a star's brightness, astronomers can tell when an exoplanet passes in front of it. Photometry is also used to measure the mass of exoplanets by observing the wobble in their star's motion. With this information, astronomers can calculate the planet's radius and get an estimate of its density. This helps them to figure out what the planet is mostly made of. But no matter what technique astronomers use, studying exoplanets is challenging because they are so far away. Most exoplanets are more than 40 light-years from Earth, making it difficult to collect enough light from them to study their atmospheres. However, scientists have developed some clever ways around this problem. For example, some telescopes are equipped with instruments that can detect tiny changes in the brightness of stars, which can indicate the presence of an exoplanet even if it's very far away. Other telescopes are designed to capture infrared light, which can penetrate dust clouds and reveal what's hiding on the other side. No matter what challenges astronomers face, they keep finding new and innovative ways to study exoplanets and learn more about them. The discovery of WASP 39b's atmosphere is just the latest example of this dedication to pushing the boundaries of what we know about the universe. If you're interested in learning more about exoplanets, check out our playlist, which has videos on everything from how astronomers find exoplanets to the latest discoveries about our solar system's next-door neighbors. We hope you will be as excited as we are about all the amazing things that are out there beyond our world. And speaking of things that are very far away, we have something a bit closer to home to talk about. If you've ever looked up at the night sky and wondered what all those twinkling lights are, chances are you've seen a satellite. There are thousands of satellites orbiting our planet, and they're getting more and more crowded. These satellites are used for all kinds of things, from communication to navigation to spy. But all this stuff in orbit is starting to get in the way of each other. Sometimes satellites can collide with each other or with pieces of space junk, and that's a problem because we don't want people to get hurt. But luckily, there are people working on this. For example, there's a group of engineers and scientists who have created a new technology that can remove satellites from orbit. Their company, Astroscale, has developed a spacecraft that can catch up with a satellite that's in trouble and then pull it out of orbit so it can burn up in the atmosphere. You know those little plastic bits that you sometimes see floating in the ocean? Well, believe it or not, there's actually a much bigger problem of space junk floating around our planet. It's estimated that there are millions of pieces of space junk in orbit, and it's creating a dangerous mess. Space junk includes everything from old satellites to bits of debris from collisions. This junk is moving so fast that even a small piece can be deadly if it hits a spacecraft. That's why it's so important to clean up all the mess we've made. And companies like Astroscale are working hard to do just that. Who knows, maybe one day soon we'll have clean skies again. It's safe to say we live in a pretty wild world. With all the crazy things that happen, it can sometimes feel like the world is full of chaos and uncertainty. But maybe that's not entirely true. Maybe there's a method to all this madness. Take, for example, the recent discovery of iron rain on the exoplanet WASP-39b. It's a pretty strange phenomenon, but it makes sense when you think about the extreme temperatures and pressures on such a planet. Similarly, the development of new technologies like Astroscale's satellite removal system is a response to the growing problem of space junk. It's a messy situation, but someone's got to deal with it. So maybe the world isn't always as random and chaotic as it seems. Maybe there's always a reason behind what's happening. It just takes a bit of curiosity and imagination to connect the dots. What do you think? Can you think of any other examples of how order emerges from chaos in the world around us? Have you heard about this amazing discovery of iron rain on WASP-39b? There was a news article that came out last week saying that astronomers have found evidence of iron rain on a very hot gas giant exoplanet. And I thought this is actually a really interesting topic to discuss today because there is a few different ways we can go with it. One way is just to talk about the discovery itself and why it is kind of strange and how it happened. Another direction we could go is more philosophical and talk about how, if there were life on such a planet, what would that mean for biology as we know it? Or we could also go in a third direction and talk about how climate change might be good for us here on Earth. Which is kind of dark, but bear with me, I will get to that. So let's start with the discovery. We don't actually have direct observation of this iron rain. What we do have is some data from the Hubble Space Telescope. And what they did was they looked at the spectrum of light that goes through this exoplanet's atmosphere, and then they looked at what part of the light spectrum gets blocked, indicating that it was absorbed by a certain chemical. Now that's not the first time that astronomers have done this to find chemicals in the atmosphere of a faraway planet. It's a pretty common method, but this time it is interesting because one of the things they found is that there is iron in the atmosphere of this exoplanet. Now the thing is though, when you look at the spectrum, it looks like the amount of iron in the atmosphere doesn't quite match what you would expect based on how much iron is in the planet's mantle. So the best explanation for this is that the iron has rained out of the atmosphere and onto the planet's surface, and they say that the rate of the rain would be about 18 kilometers or 11 miles per hour. That is very fast. And they think that the drops would be around 1 millimeter in diameter and reach 1 centimeter in length. So it's a big fat raindrop. And the temperature of these raindrops would be somewhere between 900 and 1400 degrees Celsius. So over 2000 degrees Fahrenheit. And they would fall over 100 meters per second. So very fast, very hot, very heavy raindrops. Now the reason this is weird is that we're used to rain happening on Earth under very specific conditions. It needs to be water vapor in the atmosphere. It condenses into clouds and then falls back down to the ground because gravity. But this exoplanet is a gas giant, which means it doesn't have a solid surface like Earth does. And so rain, as we understand it, shouldn't be possible. But I want to point out that this isn't the only weird weather phenomenon we've seen in other planets. For example, we've seen glass rain on Earth. Glass is silicon dioxide, and on Earth it comes from rocks containing silicon dioxide that get weathered and eroded, and then it makes its way into the atmosphere. And it forms these tiny little droplets which eventually get so heavy that they fall to the ground as little glass particles. While we've seen this happen on Earth, but we've seen it happen on Saturn's moon Titan, where there is liquid methane on the surface. Methane can condense into clouds and then it rains down as well. And we've also seen diamonds rain on Neptune. This is based on computer models of the interior of Neptune and the swings in pressure and temperature that cause carbon atoms to bond together to form diamonds bigger than grizzly bears. Now, all of this is to say that the universe is full of crazy stuff. If life could evolve to survive in any environment, then maybe iron rain isn't too surprising. But the thing is though, I don't think we'd be able to survive on a planet like this. I mean, obviously there is a lot of other things going on here that are not great for life as we understand it. 1, it's extremely hot. 2, it's very far away from the star, so it's probably very dark. 3, it's a gas giant, so there's no solid surface. You'd have to pick an air hockey puck or something to stand on. And 4, there's iron rain. So yeah, it's probably not habitable. But hey, stranger things have happened. Maybe there are some forms of life that could survive in these conditions. But the real question is, should we try to bring one to our home planet? Okay, I'm just kidding. Let's be serious again. In all honesty, I have no idea what the conditions are on this planet and if life could survive there. But if we want to discover new life, shouldn't we be looking in environments that are more similar to Earth rather than less similar to Earth? Here's what I mean. I actually think that climate change might be a good thing for humanity. Hear me out on this. Life on Earth has tended to thrive during times of rapid environmental change. If you look at the fossil record, you can see that mass extinctions tend to be followed by periods of rapid diversification and speciation, including for the ancestors of modern humans. Some researchers have even gone as far to suggest that the warming after the last ice age may have been responsible for the cognitive revolution that led to the development of modern humans. There are a lot of different factors at play here, and I don't want to oversimplify anything. But my point is that life tends to find a way to adapt and change during times of environmental stress. And so if we're talking about bringing life from another planet to Earth, well, why not bring some extremophile bacteria or fungi or something to WASP-39b? The problem is that we're kind of stuck right now. The nearest star system to ours is Alpha Centauri, and it's 4.4 light years away. So it would take a long time to get there even with today's technology, and it would be impossible to send anything back. So for now, it's just cool to know that out there in the universe there are different worlds with different environments. But while we're stuck here on Earth, we need to figure out what to do about the changes that are happening to our climate. The nice thing about science is that it gives us evidence-based knowledge about the world around us. And one of the things that the evidence has told us is that the warming we're seeing right now is caused by human activity. It's not an opinion or a belief, it's just a fact. But I think what's more important is what we choose to do about it. We could ignore the evidence and pretend like everything is fine and carry on with business as usual. Or we could listen to the scientists and make changes to help mitigate the worst effects of climate change. You can learn more about how to do that through the link below. As always, I want to thank you all for watching and being a part of this community. I hope you've learned something today, and I'll see you next time.